Hi students, welcome to our physics class. Our chapter name is Magnetic Effects of Electric Current. Today we are going to study something interesting. I am just asking you one thing. When we on the switch of fan, what is that happens? The leaves of fan is getting rotated. The leaves of fan is getting rotated in a particular direction, maybe clockwise or anti-clockwise. So, it is getting rotated. What we are doing? We are just on the switch. That means we are completing the circuit. Then the electricity is flowing and this fan is rotating, means what? The electrical energy. The electrical energy is converting to what energy? Here it happens the rotation. Rotation means the mechanical energy. Mechanical energy. So here we are giving the electrical energy and it converts to mechanical energy. That means it is rotating. We know that. Now the question is, how is this leaves are getting rotated? What is the function inside or who is rotating these leaves? Actually, inside this fan, it is having one motor, electric motor. Electric motor. So, today we want to study the function. How this electric motor is functioning. That is today's topic. Electric motor. We can see this electric motor in fan, washing machine, MP3 players, like all the devices. So, electric motor. So, already I said in the fan, what's happening it is getting rotating. The device is rotating and that converts the electrical energy to mechanical energy. And already said that we can see this in electric fan, refrigerators, mixers, washing machine, computer, MP3 players, etc. That means where we can see the rotation within the electronic devices, they have one electric motor. Now we are going to study the structure and its working. In your textbook, you can see one neat diagram. You want to study that diagram. In your examination, you want to draw that. The picture is this at page number 232. The diagram is like this. You can see two magnets are here. This is North Pole and this is South Pole. Two poles of magnet. In between these magnets, it is having a space. And in that space, you can see a rectangular column. And this is actually a coil. A insulated copper wire coil. That means a conducted wire is just made here as a coil and named it as A, B, C and D. It is just a wire is making a rectangular shape. So at the end of this, you can see a ring is connected. But the speciality of this ring is this is splitted ring or split ring. S-P-L-I-T, split ring. Not a full complete ring. It is just splitted and we call it as split ring. And it is also having certain function and we are giving such a ring here to make something in this setup. I will explain it later. So, you just want to remember, at the tip of this coil, we have two split rings and it is having the name P and Q. P and Q. P, Q. Then, in your textbook, you can see that the picture is little confusing and you want to remember these split rings are connected with the coil. Don't think that. Here you can see two brushes are there. This is extra fitting. Not this is with this structure. So here we have two brushes and its name is X and Y. It is having two brushes and these brushes are connected with wire and the circuit. So within the circuit we have batteries and a key. Closed it and connected to another brush. So this brush and the split ring have touched, but they are not fixed. That means this ring can rotate within this setup. So these brushes are here, but these rings can rotate. This brush are fixed here. This ring is not fixed. It is easy to move with this coil. So this is the setup. And which is the direction of this current through this? The current is flowing through positive to negative. So the direction is like this. The arrow to here, to here, to here, to here and to this direction. So this is the direction of current through this circuit. So I said that this is brush. Its name is like that, brush. So what is this material made of this brush? Actually we are using this brush as carbon brushes. So the electricity will flow through this. That means in this circuit the electricity will flow like this. First the electricity will come from this battery, will come to this brush, to this split ring, then to this coil, to this direction, to this, and it will come back to this split ring, then back to the brush and back to this key and the battery. This is the direction of current in this coil setup. So you want to remember the direction of this current and the flow of current. So this is the thing. Now you just want to observe that here this side is what? AB. This wire is AB and where the direction of current? The direction of current is to upside. And here you can see the current is going through the CD to downward. That means the electricity flowing through these two wires are in opposite direction. They are opposite direction. This is all about this setup. Now, what is the direction of the magnetic field? We are just placing two magnets, means in between these magnets is have magnetic field. What is the direction of this magnetic field between these magnets? I will show you the direction. The direction is like this. Always the field will start from north to south. That means north to south like this. The fields are there and we are not representing in the diagram. When we write the north and south magnets here, what it means? It means that silently within this diagram it is having magnetic field with the direction of the magnetic field is this. This is the direction of magnetic field. And in the AB, in the wire AB, the direction of current is this. That is, the current and the magnetic field is in no perpendicular direction and so there acts a particular force. We already studied. When you observe this CDY what happens here. Now the current here is in this direction to this. So here also the magnetic field is in this direction and the current is in that direction, means here also it is perpendicular and there also acts force. So this is all about this setup. Now we want to study how this is working. That is the next thing we want to explain. When we are considering this experimental setup in a three-dimensional space, it will be like this. That this coil is this. You can see here a black line. That is what? Our wire. And also here the same thing I am notating on this piece of paper. The A is here, B is here, C and D. I am representing the same thing at the bottom of the paper also. A at the bottom itself and B at the bottom, the C at the bottom and the D at the bottom also. I will tell why I am saying all this. So this is what the coil, and generally when the experiment is in three-dimensional space, the coil is like this. And we are placing the magnet north here and we are placing the south here. This is the setup. And we are just drawing this in such a manner. You just want to imagine that. So what here happens is that when we flow the electricity through this, you can see here, when we close the key, the electricity will flow through here, and here we already said. Now we want to find the direction of force acting here. We said that here current is there, magnetic field is there, both are in perpendicular direction. Then there acts what? A force. And now we want to find the direction of force acting on AB and this CD. Now we can say at the initial stage the current is flowing ABCD. At the initial stage. So in the ABCD, how the force is acting? Now I am going to find the direction of force using Fleming's left hand rule. What is the direction of the B here? This. That is, I am just putting my finger here, the forefinger to this direction. And what is the direction of current to top? That means my middle finger to top and my forefinger to this direction. And where is my thumb pointing? Inward the board. That means when we are looking the book, we can say it as it is to downward. So inside the board, I am just writing it as downward. This is about AB. In the similar way, we want to find the direction of force at this CD. Here the change is that the current is having reverse direction and the magnetic field is in the same direction. So we are just taking our fingers and putting, this is what the direction of magnetic field. I am just pointing my forefinger to this. And then what is the direction of current to down direction? That means I want to point my middle finger to down. Magnetic field, current. And then now my thumb is pointing outside the board. Or this is downward, means we can say it as upward. So this is upward. And I already said that here we have two split rings and it is easy to rotate. And actually it is rotating through one axle. Axle AXLE. That means here we have one pipe like something. Here we have some pipe like something is there. It will be projected outside. When I just draw this, it is getting confused. And that's why I am not representing it in your diagram. You can see it in your textbook. So that axle means it is having no such role in here. This split ring can rotate through that. That is the function of that. So we are talking about the direction of force acting for this magnetic field, current and the conductor. we said that it is downward and this is upward. Now just look here. The diagram is this. This is moving downward and this is upward, means what happens here? There happens half rotation. There happens half rotation. So at first it is like this. When the force acts, it starts to rotate and it will be like this now. So now you want to observe one thing. You can see that the D is here, the C is here, the B is here and the A is here. That means our coil is get turned and the direction of current is same. The direction of magnetic field is same, but our coil's direction got changed. That means now at the initial stage DC have the direction to downward about the current, but now what happens? It is to top, and at the initial stage AB is to upward with the current, but now what happens? The current is got downward. So that means our coil got changed the direction of the current. Now again we are going to apply the direction to find the direction of the force, and this is the direction is same. Then again what happens? Here the downward direction and at this side upward direction. Then again what happens? Rotation. Again the same thing happens as the similar A, B, C, D. Same of the initial, then it again rotate, rotate, rotate. Likewise, this rotation will happen. In the similar way, the fan is getting rotated. Very simple. So, in this, you want to remember something special is that when this is getting half rotated, our AB and CD is getting interchanged because of the rotation. So, why it is getting rotated? It is rotated because of this split rings. And when this is getting rotated, these split rings are moving from this to this. That means I will show you at the first stage this brush X and P and the brush Y and the split ring Q are together. When this rotation occurs, this rotation is not only for this coil but also for this split rings also. So at the first half rotation what happens? This Q will be at here and this P will be at here. That means after the half rotation this X and Y are constant or it is not able to move. So this X and Y will be here but this P will go to this X and this Q will be go to here. That means XQ and PY. It will be like that. That means this combination will be changed. That's why the current is getting reversed. Here actually you can see that. Very simple. That the AB and CD is got the current, the direction of current is got changed. And that's why it is rotating like this continuously in the same direction. Actually where here the direction is rotating, that is rotating like this, downward to this downward and this side upward here. That means here, here. We can say this is the direction of rotation. That means this is the direction of rotation. Is it clockwise or anti-clockwise? Is it clockwise or anti-clockwise? This is anti-clockwise. This is anti-clockwise. When we are doing this experiment by putting the battery in reverse manner, that means the negative here and positive here, what happens? The coil will rotate clockwise. We are studying in a particular direction and make it fix in your mind. This is all about this. So, the rotation is this. Like this. At the stage. Before the first rotation, how is our coil? Our coil is like this. That is the A, B, C and D. At this time, current is at this direction and here this direction. And so, we set this side to downward and this side to upward. Downward and upward. At this time, we have split rings at this side and also brush. It is touching and having connection also. So, this at the initial stage, this is X and this is Y and this is T and this is Q. This is before the first half rotation. When the force acts and this gets rotated, what happens is that the diagram will change like this. That is then D here, C here, B here and A here. And then what about the current? For this DC, the current is to this. That got reversed. And for the AB, here it is for top and here it is got reversed. And what about the split rings? Here also we have the split rings. The split rings have the name P and Q. Sorry, this is Q and this is P. Where the split ring connected with CD is what? Q, and where the split ring connected with AB is P. But these brushes are still, that is constant there, and that is X and Y. We are just meaning here that the brushes are still there and this split rings and the coil is getting rotated. When they are rotated, it's getting displaced and so the direction of the current is getting reversed, and that's why it is always rotating in a particular direction. If suppose that we are using a full ring here, that is we are not using a split ring, what happens? What happens is that first of all, the same thing will occur. There occurs the downward force and upward force. That means it will like this. But now the current is not reversing. That means here current is not reversing means then what happens? The current will be, the flow and the motion will be like this. If the current is not the reverse, it will not rotate like this. What happens is that it will move here, 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 here. Like a twisted motion will be only occurs. No such complete rotation will not occur if we are not using split ring. That's why we are using split ring. So, the question will be why we are using split ring in a electric motor. The reason is this: we are using split ring to change the direction of current. So, you want to remember the split ring is who change the direction of current in electric motor. And when a device changes the direction of current in a circuit, we call that substance or we call that setup called commutator. Commutator. I think this all setup is clear for you. So, we want to study about the commutator. Commutator. Commutator means it is a device. Commutator is a device that reverses the direction of flow of current, that reverses the direction of flow of current, that reverses the direction of flow of current through a circuit or in a circuit. So, here the split ring acts as commutator. You want to remember that, very important. Split ring act as commutator. So, these all are the things, and generally in your textbook they just mentioned this ABCD as a coil. But but generally we are calling this setup as armature. Armature. The thing that is rotating between the magnetic field is what? Armature. For the commercial purpose in the electric motor, we are using the armature with an iron core and some conducting wires are wounded on this. That is what? Armature in the commercial purpose. And also in this experiment we just used north and south as permanent magnets. But in commercial purpose we are using electric magnets for the proper functioning, and we can adjust the value of magnetic field and all. That's why we are using the, and also when we switch off this, we want to stop it now. That's why these all things are happen. So this is all about electric motor. In this area, you want to study the diagram first. Second, you want to study the working. That means when the current is flowing through this will go down, this will come up. That means it is rotating in anti-clockwise direction. All the things you want to study. The detailed explanation is there in your textbook, so you want to read it, and if any doubts there, please contact. It's enough for today. We will meet in next class with another topic.